The mathematics used in modern computers is identical with the mathematics that was used in ancient Egypt. And I'll show you how that works. Today, when we write a number, we work in powers of 10 and place value. We have the ones, the tens, the hundreds columns. So if you wanted to say 472, we're really saying 4 100s, 7 tens plus 2 ones. But the way that this occurs in modern computers is not place 10 value, but place 2 value. So their powers are 1s, 2s, 4s, 8s, 16s, and so forth. So if a computer wants to think of the number 16, let's say, well, if a computer wants to look at the number, let's say 14, it's 1 8, 1 4, it's 12, 1 2, and no ones. This kind of arithmetic is appropriate for computers because they deal with electricity, which can either be on, represented by 1, or off, represented by 0. The flow of electricity or no flow of electricity, these powers of 2. Now, the way the ancient Egyptians developed this can be seen in the way that they would multiply. Now, neither the ancient Egyptians nor the modern computers use a times table. Times table is something we teach children in school, and it has to be memorized. But it's really inappropriate for a computer. And I'll show you how, for example, that works. The modern computer designers, as well as the ancient Egyptians, were aware of a mathematical fact that any number can be shown to consist of the sum of powers of 2. What I mean by that is if we write the powers of 2, 1, 2, 4, 8, 16, and so forth, you notice there's a doubling going on. And any number can be represented by the sum of these. For example, if we wanted to choose the number 17, it's 16 plus 1. So I can count 1, 2, 1 plus 2 make 3, 4, 1 plus 4 make 5, 2 plus 4 make 6, 1 plus 2 plus 4 makes 7, 8, and so forth. And so any number can be represented by this, the sum of elements of this sequence. So if I wanted to multiply two numbers, let's say we wanted to multiply 17 by 25. In order to multiply the way the Egyptians did and the way that computers do, all you have to know is how to double numbers like this and how to add two numbers together. No multiplication table needed to be memorized. So 17 times 25, I've identified the elements of 17 as 1 plus 16. And in this column, I write the number 25, and I just keep doubling it. Twice 25 is 50, twice that, 100, twice that, 200, twice that, 400. So in order to know the product of 17 times 25, we just have to look at which numbers are circled over here and circle the corresponding ones over here and add them together. So 17 times 25 is 400 plus 25, or 425. It's that simple. No memorization, no times table, no tears in the 3rd grade about this. And this is how computers do it as well, except instead of circling or not circling a number, they would have a 1 or a 0. So in other words, the number 17 in binary arithmetic by computers is 10001, or electricity, no, 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 and electricity. And that will give us the sum, and that's how this works. Now, division in computers or in ancient Egypt is just the opposite of multiplication. It's the inversion. So let's say we wanted to divide 1075 by 25. Now, we don't want to use the multiplication table, nor do we want to use any kind of long division. And the way to do it is like this. Simply write out the powers of 2, 1, 2, 4, 8, 16, 32, and so forth. Here again, just the powers, the doubling of 25, 50, double that, 100, 200, 400, 800. I stopped there because if I went further, it's 1600, which is larger than 1075. And if I know that 1075 is 800 plus 200 make 1000, and 50 and 25, I just have to look across at the numbers that correspond there, or in a computer there would be an electrical circuit. And if I know that 32 plus 8 is 40, 42, 43. So 1,075 divided by 25 is 32 plus 8 plus 2 plus 1, 43. No multiplication table, no long division, no carrying, no borrowing. It's just very straightforward. Now, how did the ancient Egyptians know this? Well, I might add that also the ancient Chinese knew this. The binary system of powers of 2 is also the basis of the trigrams and hexagrams of the I Ching. The flowing nature of the universe, how things turn into one another in a flowing process in a binary kind of a pulsation. So this kind of arithmetic was also known to the Chinese as well. Now, did the modern computer people look to the ancient Egyptians or the Chinese? No. In fact, they didn't look to each other, but they all looked to the same place, and that is to the eternal principles of mathematics. And the Egyptians were quite adept at looking at eternal principles.